Close your eyes and imagine drifting above the swirling clouds of Jupiter, the largest planet in our solar system. The view is breathtaking. Bands of white, tan, and orange stretch across the planet's face, each a river of wind moving at hundreds of kilometers per hour. But your gaze is drawn to a single colossal feature, a vast oval storm colored a deep rusty red spinning endlessly in the southern hemisphere. This is the Great Red Spot, the most famous and enduring storm in the solar system, a tempest so large that it could swallow the Earth whole. The Great Red Spot is a hurricane on a scale that defies imagination. It is a high-pressure anticyclonic storm, more than 16,000 kilometers, 10,000 miles wide, about 1.3 times the diameter of Earth, and at least 300 years old, though it may be much older. First observed through telescopes in the 17th century, the red spot has been watched by astronomers for centuries, its size, color, and shape changing with time, but its presence a constant reminder of Jupiter's wild and powerful weather. What makes the Great Red Spot so extraordinary? On Earth, hurricanes and cyclones are fueled by warm ocean water and last for days or weeks before dissipating, but on Jupiter, there are no oceans. Only a deep, turbulent atmosphere of hydrogen and helium laced with ammonia, methane, and water vapor. The red spot is powered by the planet's internal heat, by the fierce winds that race around the planet, and by the complex interplay of rising and sinking air, of sunlight and shadow, of chemistry and motion. The winds at the edge of the Great Red Spot reach speeds of up to 432 kilometers per hour, 268 miles per hour, whipping the clouds into spirals and eddies, creating a boundary that separates the storm from the surrounding atmosphere. Inside the storm, the winds are calmer, but the air rises, cools, and sinks in a slow, churning motion. The color of the red spot is still a mystery. Scientists believe it may be caused by complex organic molecules, red phosphorus, or sulfur compounds, created by the sun's ultraviolet light interacting with the chemicals in Jupiter's clouds. The Great Red Spot is not alone. Jupiter's atmosphere is filled with storms, some larger than Earth's, some smaller, some lasting for years, others for only days. The planet's rapid rotation, one day on Jupiter is just under 10 hours, creates powerful jet streams that separate the bands of clouds, driving storms and turbulence, shaping the weather in ways that are both familiar and utterly alien. The red spot itself is a survivor. Over the centuries it has changed in size and color, sometimes shrinking, sometimes growing, sometimes fading to pale pink, sometimes deepening to brick red. In recent decades, the storm has been shrinking, its width decreasing, its shape becoming more circular. Some scientists wonder if the red spot is finally dying, if the greatest storm in the solar system is nearing the end of its long life. But for now, it endures, spinning on, a symbol of Jupiter's power and mystery. The Great Red Spot is also a laboratory for science. Spacecraft like Voyager, Galileo, Juno, and Hubble have studied the storm in detail, measuring its winds, its temperature, its chemistry, its magnetic field. The data reveal a world of complexity, layers of clouds, vortices and eddies, lightning and turbulence, a storm that reaches deep into Jupiter's atmosphere, perhaps as far as 300 kilometers, 200 miles, below the cloud tops. The red spot is a window into the physics of giant planets, a place where scientists can study the dynamics of fluids, the chemistry of clouds, the interplay of heat and motion. It is a reminder that weather is not just a feature of Earth, but a universal phenomenon. shaped by the same laws of nature, but expressed in ways as varied as the worlds themselves. But the great red spot is more than just a scientific curiosity. It is a source of wonder, a symbol of the power and beauty of the cosmos. To see the red spot through a telescope, to watch it drift across Jupiter's face, to imagine the winds and clouds, the lightning and rain, the endless churning of the storm, is to feel the awe that comes from witnessing something truly extraordinary. The red spot has inspired artists and writers, poets and dreamers. It has appeared in paintings and stories, in music and film, in the imagination of anyone who has ever looked up at the night sky and wondered what lies beyond. It is a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the planets is a story worth telling. As you rest in this gentle night, let yourself imagine drifting above the great red spot. Picture the swirling clouds, the bands of color, the vast spinning storm. Imagine the winds whipping past, the lightning flashing in the depths, the endless motion of the atmosphere. Feel the peace that comes with patience, the beauty that comes with power, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on a platform above the red spot, to watch the storm spin beneath you, to feel the connection between the air and the planet, the weather and the world, the past and the future. Jupiter's great red spot is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of storms to inspire awe. Take another breath. Let the story of Jupiter's greatest storm fill you with calm. Let the slow, patient journey of the red spot remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Jupiter's storms, a dreamer in the endless night. Close your eyes and imagine Saturn, the golden giant, spinning in the cold reaches of the solar system. Its rings shimmer in the sunlight, its clouds swirl in bands of cream and gold. But as you drift above Saturn's north pole, you see something that defies expectation, a perfect, six-sided shape, etched into the clouds, spinning with the planet's rotation. This is Saturn's hexagon, one of the most mysterious and beautiful weather patterns in the solar system. A storm that has puzzled scientists and inspired wonder for decades. The hexagon is a vast jet stream, a band of winds that circles Saturn's north pole at speeds of over 320 kilometers per hour, 2,000 miles per hour. It is enormous, about 30,000 kilometers, 20,000 miles across, wide enough to fit 4 Earths inside. The sides of the hexagon are straight and sharp, the angles precise, the pattern stable and enduring. First discovered by the Voyager spacecraft in the early 1980s, the hexagon has been observed ever since, its shape unchanged, its mystery deepening with every new image. What causes this extraordinary phenomenon? On Earth, jet streams are narrow bands of fast-moving air, shaped by the planet's rotation and the temperature differences between the equator and the poles. They meander and shift, but they are never regular, never geometric. On Saturn, the hexagon is unique. A polygonal jet stream, a weather pattern that seems almost artificial in its perfection. Scientists believe that the hexagon is the result of a standing wave in Saturn's atmosphere, a kind of planetary scale version of the patterns that form in fluids on a rotating sphere. In laboratory experiments, when a fluid is spun in a cylinder at the right speed, polygonal shapes can appear: triangles, squares, pentagons, hexagons, depending on the conditions. On Saturn, the combination of the planet's rapid rotation, the temperature gradient between the pole and the mid-latitudes, and the depth of the atmosphere creates the perfect conditions for a hexagonal wave to form and persist. The hexagon is not just a surface feature. It extends deep into Saturn's atmosphere, at least 300 kilometers, 200 miles down, and possibly much farther. The winds within the hexagon are among the fastest on the planet, and the pattern rotates with a period of about 10 hours and 39 minutes, the length of a Saturnian day. At the center of the hexagon, a massive hurricane spins, its eye more than 2,000 kilometers, 1,250 miles, wide, its clouds rising high above the surrounding atmosphere. The color of the hexagon changes with the seasons. During Saturn's long winter, the hexagon appears blue, its clouds clear and cold, the sunlight weak and distant. As spring and summer return, the sun's rays warm the atmosphere, and the hexagon turns gold, its clouds thickening, its colors deepening, its beauty growing. The changing hues are a reminder that even the most stable patterns are shaped by the cycles of light and darkness, by the slow, patient turning of the planet. The hexagon is also a laboratory for science. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, studied the hexagon in detail, capturing images in visible, infrared, and ultraviolet light, measuring the winds, the temperatures, the chemistry of the clouds. Cassini's data revealed the depth and structure of the hexagon, the presence of smaller storms and vortices along its edges, the complex interplay of waves and winds that sustain its shape. But the hexagon remains a mystery. Why is it so stable, so regular, so persistent? Why does it have 6 sides rather than 5 or 7? Why is there no similar pattern at Saturn's south pole, where a giant hurricane spins but no polygonal jet stream forms? The answers are still being sought in computer models, in laboratory experiments, in the patient analysis of data from Cassini and other missions. The hexagon is more than just a scientific puzzle. It is a source of wonder, a symbol of the beauty and complexity of planetary weather. To see the hexagon is to be reminded that the universe is full of surprises, that order can arise from chaos, that nature can create patterns as precise as any work of art. The hexagon is a dance of air and light, a harmony of motion and form, a masterpiece painted in clouds and wind. As you rest in this gentle night, let yourself imagine drifting above Saturn's North Pole, looking down on the hexagon. Picture the sharp, straight sides, the swirling clouds, the colors shifting with the seasons, the hurricane spinning at the center. Imagine the peace that comes with patience, the beauty that comes with order, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand at the edge of the hexagon, to feel the winds rushing past, to watch the clouds move in perfect harmony, to sense the connection between the air and the planet, the weather and the world, the past and the future. Saturn's hexagon is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of patterns to inspire awe. Take another breath. Let the story of Saturn's mysterious hexagon fill you with calm. Let the slow, patient journey of the winds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Saturn's storms, a dreamer in the endless night. Close your eyes and imagine drifting through the thick golden clouds of Venus. The N is a pale, blurry disk, its light filtered through a sky heavy with sulfuric acid and carbon dioxide. The surface below is hidden, shrouded in perpetual twilight, and the air is so dense that it would crush a submarine. But above, in the upper atmosphere, something astonishing is happening. A wind is blowing, not gently, but with relentless hurricane force. This is Venus's super-rotating atmosphere, a world where the winds circle the planet at speeds far greater than the planet itself spins, creating one of the most extreme and mysterious weather systems in the solar system. Venus is often called Earth's twin, but its atmosphere could not be more different. The planet rotates incredibly slowly. One day on Venus lasts 243 Earth days, and it spins backward compared to most planets. Yet, high above the surface, the winds whip around the planet in just 4 Earth days, reaching speeds of up to 360 kilometers per hour. 224 miles per hour. This means that the atmosphere laps the planet more than 60 times for every single rotation of the surface. The result is a phenomenon known as superrotation, a state where the air moves much faster than the ground below. The cause of this superrotation is still a subject of scientific debate. Some theories suggest that the slow rotation of Venus, combined with the intense solar heating at the equator and the cooling at the poles, sets up powerful waves and tides in the atmosphere. These waves transfer energy and momentum, accelerating the winds and maintaining their incredible speed. Other theories point to the planet's thick cloud cover, which absorbs and redistributes heat, or to the unique chemistry of the air, rich in carbon dioxide and sulfuric acid. Whatever the cause, the effect is dramatic. The clouds of Venus form a continuous planet-wide system, with bands and streaks that race around the globe. The upper atmosphere is a place of constant motion, with jet streams, vortices, and standing waves that create patterns as beautiful as they are mysterious. The most famous of these is the double-eyed vortex at the planet's poles, a swirling storm that resembles a giant hurricane spinning in the opposite direction of the planet's rotation. The super-rotating winds of Venus have profound effects on the planet's weather and climate. The fast-moving air distributes heat around the planet, making the temperature at the equator and the poles nearly the same, despite the difference in sunlight. The winds also drive the movement of clouds, creating waves and turbulence that can be seen from space. The clouds themselves are made of tiny droplets of sulfuric acid, suspended in a dense atmosphere of carbon dioxide, nitrogen, and trace gases. The result is a sky that is both beautiful and deadly, a place where lightning flashes in the clouds, where rain never reaches the ground, where the air is thick with poison. The surface of Venus is a world of extremes. The pressure is more than 90 times that of Earth. The temperature is hot enough to melt lead, and the air is filled with corrosive gases. The winds at the surface are much slower than those above, but they are still strong enough to move sand and dust, to shape the landscape, to create dunes and ripples in the volcanic plains. The super-rotation of the upper atmosphere is a reminder that the air above and the ground below are connected, that the dance of the winds shapes the face of the planet. Venus's super-rotating atmosphere is not just a scientific curiosity, it is a challenge and an inspiration. Spacecraft like Venera, Magellan, Venus Express, and Akatsuki have braved the planet's hostile environment to study its clouds, its winds, its chemistry, and its mysteries. Their data have revealed a world of complexity and beauty, a place where the laws of physics play out in ways both familiar and strange. The study of Venus's atmosphere is also a window into the past and future of Earth. Venus and Earth are similar in size and composition, but their climates could not be more different. Understanding why Venus became a world of runaway greenhouse effect, super-rotating winds, and acid clouds may help us understand the limits of habitability, the dangers of climate change, and the delicate balance that keeps our own planet alive. But Venus's atmosphere is also a source of wonder. To imagine standing in the upper clouds, where the temperature and pressure are almost Earth-like, is to dream of floating cities, of airships drifting through golden skies, of explorers gazing down on a world hidden by clouds. The winds would carry you around the planet in just a few days, a journey of endless sunrise and sunset, a dance of light and shadow, of beauty and danger. As you rest in this gentle night, let yourself imagine the super-rotating winds of Venus. Picture the clouds racing around the planet, the patterns shifting and changing, the air moving faster than the ground below. Imagine the peace that comes with patience, the beauty that comes with motion, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to drift in the clouds of Venus, to feel the wind on your face, to watch the sun rise in the west and set in the east, to see the world through the golden haze, to sense the connection between the air and the planet, the weather and the world, the past and the future. Venus's super-rotating atmosphere is a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of winds to inspire awe. Take another breath. Let the story of Venus's wild winds fill you with calm. Let the slow, patient journey of the clouds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Venus's atmosphere, a dreamer in the endless night. Close your eyes and imagine standing on the surface of Mars. The sky is a pale salmon pink, the ground a rusty red, and the horizon stretches on forever, broken only by distant mountains and the faint outline of ancient riverbeds. The air is thin and cold, the wind is gentle, at first, but then, almost without warning, the wind begins to rise. Dust lifts from the ground, swirling in small eddies, then in great rolling clouds. The sky darkens, the sun fades to a dim orange disk, and the world is swallowed by a storm that will last for weeks, even months. This is the story of Mars's global dust storms, the most dramatic and far-reaching weather events on the red planet, storms to Hat can cover the entire world and plunge it into darkness. Mars is a world of extremes, and its weather is no exception. The planet's atmosphere is thin, less than 1% the pressure of Earth's, and made mostly of carbon dioxide. There is little water vapor, no oceans, and only the faintest traces of clouds. But the surface is covered in fine, dry dust, rich in iron oxide, the mineral that gives Mars its red color. This dust is easily lifted by the wind, and once airborne, it can travel vast distances, carried by the planet's powerful jet streams and global circulation. Dust storms on Mars come in many sizes. Some are small local events, dust devils that dance across the plains, leaving twisting tracks in the sand. Others are regional, covering thousands of square kilometers, obscuring craters and valleys, and changing the landscape for weeks at a time. But every few years, when the conditions are just right, a storm will grow and grow, merging with others, until it becomes a global dust storm, a planet-wide event that can last for months and block out the sun across the entire world. The triggers for these storms are still not fully understood. They often begin in the southern spring and summer when Mars is closest to the sun and the temperature difference between the hemispheres is greatest. The increased sunlight heats the surface, creating strong winds that lift dust into the air. As the dust rises, it absorbs more sunlight, heating the atmosphere and creating even stronger winds, a feedback loop that can quickly spiral out of control. Once a global dust storm begins, it can cover Mars in a matter of days. The sky darkens, the temperature drops, and the sun becomes a faint, reddish glow. The dust can reach heights of 60 kilometers, 37 miles or more, circling the planet, settling slowly and sometimes remaining suspended for weeks or months. The storms can last for up to half a Martian year, about 6 months on Earth, before finally subsiding, leaving the surface coated in a fresh layer of dust. The effects of these storms are dramatic. The loss of sunlight can plunge the surface into a deep freeze, threatening the survival of robotic explorers and one day human settlers. Solar panels become coated with dust, reducing their efficiency and sometimes forcing missions to shut down or hibernate until the skies clear. The thin air and low gravity mean that the dust can remain suspended for a long time, creating a persistent haze that changes the color of the sky and the appearance of the landscape. But the storms are not just a challenge, they are also a source of wonder. The dust devils that dance across the plains are beautiful, twisting columns of air that can reach heights of several kilometers, their paths traced by the tracks they leave behind. The regional storms create patterns of light and shadow, revealing the topography of the land, the shapes of craters and valleys, the history of erosion and deposition. The global storms are a reminder of the power of nature, of the way small changes can lead to dramatic consequences, of the interconnectedness of air, land, and sun. They are a lesson in patience, in resilience, in the ability of life and machines to adapt to the most challenging environments. The study of Martian dust storms is also a window into the planet's past and future. The patterns of dust and sand, the layers of sediment, the chemistry of the air, all tell the story of a world that was once warmer and wetter, with rivers and lakes, perhaps even oceans. The storms may have played a role in the loss of Mars's atmosphere, stripping away water and gases, leaving the planet dry and cold. They may also shape the future, influencing the climate, the potential for life, the challenges of exploration and settlement. As you rest in this gentle night, let yourself imagine the world of Mars during a global dust storm. Picture the sky darkening, the wind rising, the dust swirling in great rolling clouds, the sun fading to a dim orange disk. Imagine the silence, the patience, the beauty of a world transformed by air and dust, by the dance of the atmosphere, by the power of weather on a planetary scale. Let yourself wonder what it would be like to stand on the surface of Mars during a storm, to feel the wind on your face, to watch the landscape disappear into the haze, to wait for the sun to return, to see the world anew when the dust finally settles. Mars's global dust storms are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of weather to inspire awe. Take another breath. Let the story of Mars's storms fill you with calm. Let the slow, patient journey of the dust remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Martian weather, a dreamer in the endless night. Close your eyes and imagine drifting to the farthest reaches of the solar system where the sun is just a bright star in a deep blue sky. Here on Neptune, the eighth and most distant planet, the air is cold and thin, the clouds are streaked with methane, and the world is wrapped in a perpetual twilight. But beneath this calm, blue exterior, something astonishing is happening. The winds are howling, racing around the planet at speeds that defy imagination. This is the story of Neptune's supersonic winds, the fastest, wildest weather in the solar system. Neptune is a world of extremes. Its atmosphere is made mostly of hydrogen and helium, with a touch of methane that gives the planet its striking blue color. The temperature at the cloud tops is a frigid minus 218 degrees Celsius, minus 360 degrees Fahrenheit, colder than anywhere else in the solar system. Yet, despite this deep freeze, Neptune's weather is anything but still. The planet's winds can reach speeds of over 2,000 kilometers per hour, 1,200 miles per hour, faster than the speed of sound on Earth, and faster than any hurricane, tornado, or jet stream our planet has ever known. What drives these incredible winds? The answer is still a mystery. Neptune is far from the sun, receiving only a tiny fraction of the sunlight that warms Earth or even Jupiter. Yet the planet radiates more than twice as much energy as it receives, suggesting that it has an internal heat source, perhaps the slow contraction of the planet, or the decay of radioactive elements deep within. This heat rises through the atmosphere, creating convection currents, driving storms, and powering the winds. The winds on Neptune are not just fast, they are organized into powerful jet streams that circle the planet in bands, much like the stripes on Jupiter and Saturn. The fastest winds are found near the equator, where they blow westward, while slower eastward winds dominate the higher latitudes. The boundaries between these bands are marked by sharp changes in speed and direction, creating turbulence, vortices, and storms. One of the most famous features of Neptune's atmosphere is the Great Dark Spot, a massive storm system first observed by the Voyager 2 spacecraft in 1989. The Great Dark Spot was similar in size and appearance to Jupiter's Great Red Spot, but it was short-lived, disappearing within a few years and replaced by new storms in other locations. These dark spots are thought to be giant vortices, spinning columns of air that rise and fall, creating clouds of methane ice and driving the planet's wildest weather. The clouds on Neptune are also remarkable. High above the main cloud deck, thin, bright clouds of methane ice race across the sky, casting shadows on the deeper layers below. These clouds move at incredible speeds, sometimes forming wave patterns or trailing behind the dark spots like the tail of a comet. The contrast between the deep blue of the planet and the white of the clouds creates a landscape of surreal beauty, a world where the air is always in motion, where the weather is always changing. The study of Neptune's winds is a challenge. The planet is far from Earth, and only one spacecraft, Voyager 2, has ever visited, flying by in a brief encounter more than 30 years ago. Most of what we know comes from telescopes, both on the ground and in space, which track the movement of clouds and storms, measure the temperature and company and position of the air, and model the dynamics of the atmosphere. The data reveal a world of complexity, a place where the laws of physics play out in ways both familiar and strange. Neptune's supersonic winds are not just a scientific curiosity, they are a source of wonder. To imagine standing in the upper atmosphere, feeling the wind rush past at more than 2,000 kilometers per hour, is to dream of a world where the air is alive, where the weather is a force of nature, where the boundaries between calm and chaos are always shifting. The winds are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. The winds also have lessons for Earth. They show us the power of internal heat, the importance of energy balance, the role of chemistry and dynamics in shaping weather and climate. They remind us that the air is not just a backdrop, but a living, changing system, shaped by the interplay of sunlight, heat, and motion. As you rest in this gentle night, let yourself imagine drifting above Neptune's clouds, watching the winds race across the planet, feeling the power of the atmosphere, the beauty of the blue, the wonder of a world where the air moves faster than sound. Imagine the peace that comes with patience, the excitement that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to ride the winds of Neptune, to see the storms form and fade, to watch the clouds move in endless patterns, to feel the connection between the air and the planet, the weather and the world, the past and the future. Neptune's supersonic winds are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of winds to inspire awe. Take another breath. Let the story of Neptune's wild winds fill you with calm. Let the slow, patient journey of the clouds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Neptune's storms, a dreamer in the endless night. Close your eyes and imagine drifting to the edge of the solar system, where the sun is just a pale, distant star and the air is colder than any place on Earth. Here you find Uranus, a world of blue-green clouds, a planet that spins on its side, and a place where weather is both subtle and strange. Uranus is a world of mystery, and its atmosphere is home to some of the most unusual storms and clouds in the solar system, shaped by methane, cold, and a tilt that defies expectation. Uranus is unique among the planets. Its axis is tilted by 98 degrees, so it rolls around the sun like a ball on its side. This means that for decades at a time, one pole is bathed in sunlight while the other is plunged into darkness. The seasons on Uranus are the longest in the solar system, each lasting more than 20 Earth years. The result is a climate that is both extreme and subtle, a world where the sun's warmth is spread unevenly, and the atmosphere responds in ways that are still not fully understood. The air on Uranus is made mostly of hydrogen and helium, but it is the methane that gives the planet its distinctive blue-green color. Methane absorbs red light and reflects blue, painting the clouds in shades of turquoise and teal. But methane is more than just a pigment. It is also a key player in the planet's weather. High in the atmosphere, methane condenses into ice crystals, forming thin, bright clouds that race around the planet, driven by winds that can reach speeds of up to 900 kilometers per hour, 560 miles per hour. The storms on Uranus are not as dramatic as those on Jupiter or Neptune, but they are no less fascinating. Most of the time, the planet's clouds are smooth and featureless, a calm pastel disk in the sky. But every so often, bright spots and bands appear, storms that rise from the depths, bringing methane ice and other gases to the surface, creating patterns that can last for days or weeks. These storms are often seen near the equator or at the edges of the polar regions, their shapes and movements a puzzle for scientists. The most famous of these storms was the bright spot, observed by the Hubble Space Telescope in 2014, a massive white cloud system that appeared suddenly and then faded away, its cause still unknown. Other storms have been seen by ground-based telescopes and by the Voyager 2 spacecraft, which flew by Uranus in 1986 and captured the first close-up images of the planet's atmosphere. The sideways rotation of Uranus adds another layer of complexity to its weather. The planet's poles receive more sunlight than the equator, but the atmosphere seems to distribute heat evenly, creating jet streams and bands that circle the planet. The winds blow mostly in the direction of rotation, but their speed and direction can change with the seasons, with storms and clouds appearing and disappearing in response. The methane ice clouds of Uranus are a reminder that weather is not just a feature of Earth, but a universal phenomenon shaped by the same laws of physics but expressed in ways as varied as the worlds themselves. The clouds are thin and high, their crystals reflecting sunlight, their patterns shifting with the winds, their beauty subtle and serene. The study of Uranus's atmosphere is a challenge. The planet is far from Earth and only one spacecraft, Voyager 2, has ever visited, flying by in a brief encounter more than 35 years ago. Most of what we know comes from telescopes, both on the ground and in space, which track the movement of clouds and storms, measure the temperature and composition of the air, and model the dynamics of the atmosphere. The data reveal a world of complexity, a place where the laws of physics play out in ways both familiar and strange. Uranus's methane ice clouds are not just a scientific curiosity, they are a source of wonder. To imagine standing in the upper atmosphere, feeling the wind rush past, watching the clouds move in endless patterns, is to dream of a world where the air is alive, where the weather is a force of nature, where the boundaries between calm and chaos are always shifting. The clouds are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. The sideways world of Uranus also has lessons for Earth. It shows us the power of tilt and rotation, the importance of energy balance, the role of chemistry and dynamics in shaping weather and climate. It reminds us that the air is not just a backdrop, but a living, changing system shaped by the interplay of sunlight, heat, and motion. As you rest in this gentle night, let yourself imagine drifting above Uranus's clouds, watching the methane ice crystals shimmer in the pale sunlight, feeling the power of the winds, the beauty of the blue-green world, the wonder of a planet that spins on its side. Imagine the peace that comes with patience, the excitement that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to ride the winds of Uranus, to see the storms form and fade, to watch the clouds move in endless patterns, to feel the connection between the air and the planet, the weather and the world, the past and the future. Uranus's methane ice clouds are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the Endu ring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of clouds to inspire awe. Take another breath. Let the story of Uranus's strange storms fill you with calm. Let the slow, patient journey of the clouds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Uranus's weather, a dreamer in the endless night. Close your eyes and imagine the Earth as seen from space, a swirling blue marble, alive with motion, its surface and atmosphere in constant dance. As you look closer, you see patterns forming in the clouds, vast spirals over the oceans, tight whirls over the land, storms that rage with a power unmatched by anything else on our planet. These are hurricanes and tornadoes, the most powerful and dramatic weather events on Earth, born from the interplay of heat, moisture, and the restless energy of the air. A hurricane, also known as a typhoon or cyclone depending on where it forms, is a colossal engine of wind and water. It begins as a cluster of thunderstorms over warm ocean waters, where the sun's heat evaporates water, filling the air with moisture. As the warm, moist air rises, it cools and condenses, releasing heat and creating a low-pressure center. The surrounding air rushes in, spinning due to the Coriolis effect, and the storm begins to rotate. If conditions are right, if the ocean is warm enough, the air humid enough, and the winds aloft gentle enough, the storm grows, feeding on the heat of the sea, organizing into a vast spiraling system. At the heart of the hurricane is the eye, a calm, clear center where the winds are light and the sky is often blue. Surrounding the eye is the eye wall, a ring of towering clouds and the most intense winds and rain. The spiral arms, or rain bands, stretch out for hundreds of kilometers, bringing heavy rain, thunderstorms, and gusty winds. A mature hurricane can be more than 1,000 kilometers, 600 miles across, with sustained winds of over 250 kilometers per hour, 155 miles per hour, and can release as much energy in a day as all the world's power plants combined. Hurricanes are both beautiful and terrifying. From space, they are works of art, perfect spirals of white cloud moving across the blue ocean, their structure elegant and precise. but on the ground they are forces of destruction, bringing storm surges, flooding, and wind that can flatten cities, uproot forests, and reshape coastlines. The power of a hurricane is a reminder of the energy stored in the oceans, the complexity of the atmosphere, the fragility of human life in the face of nature's might. Tornadoes are smaller, but no less dramatic. They form in powerful thunderstorms, where warm, moist air meets cold, dry air, creating instability and turbulence. As the storm develops, winds at different altitudes blow at different speeds and directions, creating a horizontal tube of spinning air. Updrafts tilt this tube upright, and the rotation tightens, forming a funnel cloud that reaches toward the ground. When the funnel touches down, it becomes a tornado, a column of air spinning at speeds of up to 500 kilometers per hour. 310 miles per hour, capable of tearing buildings from their foundations, hurling cars through the air, and scouring the land clean. Tornadoes are among the most violent storms on Earth, but they are also among the most fleeting. Most last only a few minutes, travel a few kilometers, and dissipate as quickly as they form. But some, known as supercell tornadoes, can last for hours, carving paths of destruction dozens or even hundreds of kilometers long. The largest tornadoes can be more than a kilometer wide, their power concentrated in a narrow, twisting column of wind and debris. The science of hurricanes and tornadoes is a story of energy, motion, balance. Both storms are fueled by the transfer of heat from the surface to the atmosphere, by the condensation of water vapor, by the rotation of the earth, and by the complex interactions of wind, temperature, and pressure. Both are shaped by the landscape, by the warmth of the ocean, the flatness of the plains, the presence of mountains and forests. Both are studied with satellites, radar, aircraft, and computer models, their paths and power predicted with increasing accuracy, their mysteries slowly unraveled. But hurricanes and tornadoes are also a source of wonder. They are reminders of the power and beauty of the natural world, of the energy that flows through the air and water, of the patterns that emerge from chaos. They are a challenge and an inspiration, a test of resilience and adaptation, a call to respect and understand the forces that shape our planet. As you rest in this gentle night, let yourself imagine the dance of hurricanes and tornadoes. Picture the spiral of a hurricane over the ocean, the eye calm and clear, the winds howling in the eye wall, the rain bands stretching out like arms. Imagine the twisting funnel of a tornado reaching from the clouds to the ground, spinning with unimaginable speed, moving across the land in a dance of power and grace. Let yourself wonder what it would be like to witness these storms from above, to see the patterns in the clouds, to feel the energy in the air, to sense the connection between the ocean and the sky, the land and the wind, the past and the future. Hurricanes and tornadoes are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of storms to inspire awe. Take another breath. Let the story of Earth's wildest weather fill you with calm. Let the slow, patient journey of the clouds and winds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler on Earth, a witness to the quiet dance of storms, a dreamer in the endless night. Close your eyes and imagine a world where the ground is never still, where the air is filled with the scent of sulfur, and where volcanoes erupt with a fury unmatched anywhere else in the solar system. This is Io, the innermost of Jupiter's 4 great Galilean moons, a place so geologically active that its surface is constantly being remade by fire and ash. Here, volcanic plumes rise hundreds of kilometers above the ground, painting the sky with clouds of sulfur and dust, creating a landscape that is both alien and awe-inspiring. Io is a world of extremes. Its surface is a patchwork of yellow, orange, red, and white, colored by sulfur compounds and frosts. On gases, there are no craters here. Every impact scar is quickly buried by new lava, every old feature erased by the relentless activity below. More than 400 active volcanoes dot the surface, some of them larger than any found on Earth. The most powerful, like Pele and Loki, are true giants, their eruptions visible from space, their plumes reaching heights of 300 kilometers, 190 miles or more. What drives this extraordinary volcanism? The answer lies in the dance of gravity. Io is caught in a tug-of-war between Jupiter and its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, the gravity of the giant planet and the tugs from the other moons flex and squeeze Io's interior, generating immense heat through friction. This process, called tidal heating, melts rock, creates magma, and powers the endless eruptions that shape the moon's surface. The volcanic plumes of Io are among the most spectacular sights in the solar system. When a volcano erupts, it blasts sulfur dioxide gas, molten rock, and fine dust high into the sky. The plumes spread out in umbrella-shaped clouds, casting shadows on the ground, falling back as frost and ash, and sometimes escaping into space to form a thin, temporary atmosphere. The material ejected by these eruptions is so abundant that it creates a torus, a giant ring of gas and dust, that encircles Jupiter, feeding the planet's powerful radiation belts and painting the other moons with sulfur. The colors of Io are a testament to its volcanic nature. The yellows and oranges come from sulfur and its compounds, deposited by the plumes and altered by the sun's radiation. The reds and blacks are from molten lava, cooling and solidifying on the surface. The whites are from sulfur dioxide frost, condensing in the cold, thin air. The result is a world that looks like a painting, a place where geology is art, where every eruption creates a new masterpiece. The study of Io's volcanic plumes is a window into the power of tidal heating, the dynamics of planetary interiors, and the chemistry of exotic worlds. Spacecraft like Voyager, Galileo, and Juno have captured images and data, revealing the heights of the plumes, the temperatures of the lava, the composition of the gases. Scientists have watched as new volcanoes appeared, old ones faded, and the surface changed before their eyes. A reminder that Io is alive, restless, and ever-changing. Io's volcanism is not just a scientific curiosity, it is a source of wonder. To imagine standing on the surface, watching a plume rise into the sky, feeling the ground tremble, seeing the colors shift and change, is to dream of a world where the forces of nature are unleashed in their purest form. The plumes are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. The volcanic activity on Io also has lessons for Earth. It shows us the power of tidal forces, the importance of internal heat, the role of chemistry and dynamics in shaping landscapes and climates. It reminds us that the air is not just a backdrop, but a living, changing system, shaped by the interplay of energy, matter, and motion. As you rest in this gentle night, let yourself imagine drifting above Io's surface, watching the volcanic plumes rise and fall, feeling the power of the eruptions, the beauty, the colors, the wonder of a world where the air is filled with fire and dust. Imagine the peace that comes with patience, the excitement that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on Io, to see the sky painted with sulfur and ash, to watch the ground change with every eruption, to feel the connection between the air and the land, the volcanoes and the world, the past and the future. Io's volcanic plumes are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony and connection, in the power of nature to create order from chaos, and the power of volcanoes to inspire awe. Take another breath. Let the story of Io's wild eruptions fill you with calm. Let the slow, patient journey of the plumes remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Io's volcanoes, a dreamer in the endless night. Close your eyes and imagine a world where the rain is not water, but methane, where rivers carve their way through icy plains, not with liquid water, but with liquid natural gas, where lakes and seas shimmer in the golden twilight, reflecting the pale glow of a distant sun. This is Titan, Saturn's largest moon, a world that is both alien and strangely familiar, a place where the weather is wild, the air is thick, and the landscape is shaped by a cycle of rain, rivers, and lakes unlike anything on Earth. Titan is the only moon in the solar system with a dense atmosphere, and it is the only place besides Earth known to have stable liquids on its surface. But Titan's air is not like ours. It is made mostly of nitrogen, with a touch of methane and other hydrocarbons. The temperature is a frigid minus 179 degrees Celsius, minus 290 degrees Fahrenheit, cold enough that water is as hard as rock, and methane and ethane, gases on Earth, are liquids that flow, pool, and evaporate. The weather on Titan is a dance of methane. In the warmth of the summer sun, methane evaporates from the lakes and seas near the poles, rising into the thick orange haze that fills the sky. Clouds form, drifting across the landscape, sometimes growing into massive storm systems that stretch for hundreds of kilometers. When the clouds grow heavy, methane rain falls to the ground, sometimes in gentle drizzles, sometimes in torrential downpours that can flood the land and reshape the surface. The rain carves channels and valleys, creating riverbeds that wind through the icy plains, cutting canyons and deltas, carrying sediment and organic material. Some of the rivers flow into vast lakes and seas, bodies of liquid methane and ethane that cover hundreds of square kilometers, their surfaces rippled by wind, their shores shaped by waves and tides. The largest of these seas, Kraken Mare and Legia Mare, are as big as the Great Lakes of North America, their depths still unknown, their mysteries waiting to be explored. The cycle of methane on Titan is a mirror of the water cycle on Earth. There is evaporation, condensation, precipitation, runoff, and infiltration. There are clouds and rain, rivers and lakes, storms and floods. The landscape is shaped by the flow of liquid, the movement of air, the interplay of chemistry and climate. The result is a world that is both alien and familiar, a place where the processes that shape the land are the same, but the materials are different. The study of Titan's weather is a triumph of exploration and technology. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, and its companion, the Huygens probe, which landed on Titan in 2005, revealed the moon's secrets in stunning detail. Radar images showed the shapes of lakes and rivers, infrared sensors detected clouds and rain, and the Huygens lander sent back pictures of rounded pebbles, evidence of ancient streams and floods. Titan's methane rain and lakes are not just a scientific curiosity, they are a source of wonder. To imagine standing on the shore of a methane sea, watching the rain fall from a golden sky, feeling the cold wind on your face, is to dream of a world where the familiar is made strange, where the boundaries between Earth and elsewhere are blurred. The lakes and rivers are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. The weather on Titan also has lessons for Earth. It shows us the power of cycles, the importance of energy balance, the role of chemistry and dynamics in shaping landscapes and climates. It reminds us that the air is not just a backdrop, but a living, changing system shaped by the interplay of sunlight, heat, and motion. Titan's methane cycle is also a window into the possibilities for life. Some scientists speculate that exotic forms of life could exist in the cold, liquid methane, using chemistry very different from that of Earth. The lakes and rivers are laboratories for the imagination, places where the boundaries of biology are tested, where the potential for life is expanded. As you rest in this gentle night, let yourself imagine drifting above Titan's surface, watching the clouds form and rain fall, seeing the rivers wind through the plains, the lakes shimmer in the twilight, the landscape change with the seasons. Imagine the peace that comes with patience, the excitement that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to walk on Titan, to feel the crunch of icy ground beneath your feet, to watch the methane rain fall, to see the lakes and rivers, to sense the connection between the air and the land, the weather and the world, the past and the future. Titan's methane rain and lakes are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of weather to inspire awe. Take another breath. Let the story of Titan's alien weather fill you with calm. Let the slow, patient journey of the clouds and rain remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Titan's methane cycle, a dreamer in the endless night. Close your eyes and imagine a world of ice, orbiting far from the sun, where the surface is as hard as granite and the air is almost non-existent. This is Europa, one of Jupiter's most intriguing moons, a place where the landscape is a frozen shell, but where, beneath the surface, a hidden ocean may be waiting. And every so often, in the silence of space, something extraordinary happens. A plume of water vapor erupts from the ice, shooting hundreds of kilometers into the sky, a geyser that hints at the secrets below. Europa is a world of paradoxes. Its surface is bright and smooth, crisscrossed by dark lines and ridges, evidence of a restless, shifting shell. The temperature at the surface is a frigid minus 160 degrees Celsius, minus 260 degrees Fahrenheit, cold enough to keep water frozen as hard as rock. But beneath this icy crust, scientists believe there is a global ocean, twice as much water as all of Earth's oceans combined, kept liquid by the heat generated as Europa is flexed and squeezed by Jupiter's immense gravity. The evidence for this hidden ocean comes from many sources: the way Europa's surface moves and cracks, the magnetic field that suggests a salty conductive sea, the patterns of chaos terrain where the ice is broken and refrozen. But perhaps the most dramatic evidence comes from the plumes, jets of water vapor that have been detected erupting from the surface, carrying material from the ocean below into space. These plumes were first hinted at by the Galileo spacecraft in the 1990s and later confirmed by the Hubble Space Telescope and other instruments. The plumes are not constant. They appear and disappear, sometimes erupting from the same location, sometimes from new spots. When they erupt, they shoot water vapor, ice particles, and organic molecule hundreds of kilometers above the surface, creating a temporary atmosphere, a thin veil of mist that is quickly lost to space or falls back as frost. The plumes of Europa are a window into the moon's interior. By studying the composition of the plumes, scientists can learn about the chemistry of the ocean below, its salinity, its temperature, its potential for life. The plumes may carry not just water but salts, minerals, and even the building blocks of life, ejected from the ocean through cracks in the ice, brought to the surface by the tides and heat of Jupiter's pull. The possibility of sampling Europa's ocean without drilling through kilometers of ice is a dream for planetary scientists. Future missions, like NASA's Europa Clipper, are designed to fly through the plumes, collecting and analyzing the material, searching for signs of habitability, and perhaps even life itself. The plumes are a natural laboratory, a place where the secrets of the deep are brought to the surface, where the boundaries between ocean and space are blurred. The plumes are also a source of wonder. To imagine standing on Europa's surface, watching a geyser erupt into the sky, seeing the sunlight catch the ice crystals, feeling the ground tremble with the force of the eruption, is to dream of a world where the familiar is made strange, where the boundaries of possibility are expanded. The plumes are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. Europa's plumes are not just a scientific curiosity, they are a symbol of hope. They suggest that the ocean below is active, dynamic, and connected to the surface. They hint at the possibility of hydrothermal vents, of chemical gradients, of energy sources that could support life. On Earth, life thrives in the darkness of the deep ocean, feeding on the heat and minerals from vents. Could the same be true on Europa? Could the plumes be carrying not just water and salts, but the signatures of living organisms? The study of Europa's plumes is a challenge. The eruptions are rare and unpredictable. The material is quickly lost to space, and the moon is far from Earth, difficult to reach and explore. But with each new observation, each new mission, the picture becomes clearer, the possibilities more exciting, the hope more real. As you rest in this gentle night, let yourself imagine drifting above Europa's surface, watching a plume erupt from the ice, seeing the water vapor rise into the sky, feeling the connection between the ocean below and the space above. Imagine the peace that comes with patience, the excitement that comes with discovery, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to sample the plumes, to taste the ocean of another world, to search for signs of life in the mist, to feel the connection between the air and the water, the ice and the ocean, the past and the future. Europa's water vapor plumes are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of Teet, the atmosphere, is a lesson in harmony and connection, in the power of nature to create order from chaos, and in the power of water to inspire awe. Take another breath. Let the story of Europa's hidden ocean and erupting plumes fill you with calm. Let the slow, patient journey of the water remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Europa's geysers, a dreamer in the endless night. Close your eyes and imagine standing on the surface of Mercury, the innermost planet of the solar system. The sun looms huge and blinding in the sky, its light so intense that the ground beneath your feet glows with heat. There is no air to carry sound, no clouds to soften the light, no wind to cool your skin. The world is silent, stark, and utterly exposed. But as the sun sets and darkness falls, the temperature plummets and the heat of the day is lost to the cold of space. This is Mercury, a world of extreme temperature swings, where the difference between day and night can be more than 1,000 degrees, 550 degrees Celsius, the most dramatic in the solar system. Mercury is a planet of paradoxes. It is the closest world to the sun, orbiting at an average distance of just 58 million kilometers, 36 million miles. The sun from Mercury's surface appears more than twice as large as it does from Earth, and sunlight is up to 7 times more intense. Yet, despite this proximity, Mercury is not the hottest planet. That title belongs to Venus, with its thick heat-trapping atmosphere. Mercury, by contrast, has almost no atmosphere at all. Its air is a whisper, a thin exosphere of atoms blasted from the surface by solar radiation and the solar wind. Because Mercury lacks a substantial atmosphere, it cannot retain heat. During the long Mercurian day, which lasts about 59 Earth days, the surface is baked by the sun, reaching temperatures of up to 430 degrees Celsius, 800 degrees Fahrenheit. Rocks and dust absorb the energy, and the ground becomes so hot that lead would melt and any water or ice would instantly vaporize. The landscape is a study in extremes, craters and cliffs, ridges and plains, all scorched by relentless sunlight. But as the sun sets, the story changes. With no air to trap the heat, the surface cools rapidly, radiating its energy into the blackness of space. The temperature drops to minus 180 degrees Celsius, minus 290 degrees Fahrenheit, or lower, colder than the surface of Pluto. The night on Mercury is long, almost 59 Earth days of darkness, and the cold is absolute, freezing everything in its grasp. The difference between the hottest day and the coldest night is more than 600 degrees Celsius, 1,100 degrees, a swing unmatched anywhere else in the solar system. These temperature extremes have profound effects on Mercury's surface in geology. The constant heating and cooling cause rocks to expand and contract, creating cracks and fractures, breaking down boulders into dust. The lack of atmosphere means that meteorites strike the surface unimpeded, creating craters and scars that last for billions of years. The planet's surface is ancient, a record of impacts and eruptions, of heat and cold, of the relentless passage of time. The temperature swings also create unique features. In some craters near the poles, the sun never rises above the rim, and the floors remain in perpetual shadow. These cold traps are among the coldest places in the solar system, and they harbor deposits of water ice, preserved for eons despite the planet's proximity to the sun. The ice is a paradox, a reminder that even in the hottest places, cold can endure, that the dance of temperature is a story of balance and extremes. Mercury's rotation adds another layer of complexity. The planet spins slowly, but its year is short. Just 88 Earth days, because of a 3-2 resonance between its rotation and orbit. A single day on Mercury, from one sunrise to the next, lasts 176 Earth days. This means that the same side of the planet faces the sun at each perihelion, and the cycle of heating and cooling is both long and intense. The study of Mercury's temperature swings is a window into the physics of heat, the dynamics of airless worlds, and the challenges of survival in extreme environments. Spacecraft like Mariner 10 and Messenger have mapped the planet's surface, measured its temperatures, and revealed the patterns of heat and cold, the distribution of ice, the history of impacts and volcanism. Mercury's extremes are not just a scientific curiosity, they are a source of wonder. To imagine standing on the surface, feeling the heat of the day, the cold of the night, the silence of a world without air, is to dream of a place where the boundaries of possibility are stretched, where the familiar is made strange, where the dance of temperature is a story worth telling. The temperature swings on Mercury also have lessons for Earth. They show us the importance of the atmosphere, the power of air to trap heat, to moderate climate, to make life possible. They remind us that the balance of energy is delicate, that the loss of air can turn a world into a place of extremes, that the dance of heat and cold is a story of connection and change. As you rest in this gentle night, let yourself imagine the world of Mercury. Picture the sun rising over a cratered horizon, the ground heating with every hour, the rocks glowing with energy. Then imagine the sun setting, the darkness falling, the heat fleeing into space, the surface freezing in the silence of night. Imagine the peace that comes with patience, the beauty that comes with extremes, the hope that comes with knowing that you are part of a universe that is both ancient and ever new. Let yourself wonder what it would be like to stand on Mercury, to feel the heat and the cold, to watch the sun rise and set in slow motion, to sense the connection between the air and the land, the temperature and the world, the past and the future. Mercury's extreme temperature swings are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of heat and cold to inspire awe. Take another breath. Let the story of Mercury's wild temperatures fill you with calm. Let the slow, patient journey of the planet remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Mercury's extremes, a dreamer in the endless night. your eyes and imagine drifting to the farthest reaches of the solar system, where the sun is just a bright star in a black sky. Here, on the edge of the Kuiper Belt, you find Pluto, a world once called the ninth planet, now known as a dwarf planet, but no less mysterious or beautiful. Pluto is a place of paradoxes. Its surface is frozen, its air is thin, and yet, even here, the winds blow. These are Pluto's nitrogen ice winds, subtle but powerful, shaping dunes, moving glaciers and sculpting the landscape in a dance of cold and light. Pluto's surface is a patchwork of colors and textures: white plains of nitrogen ice, dark streaks of organic compounds, mountains of water ice as hard as granite, and vast heart-shaped basins. The most famous of these is Sputnik Planitia, a frozen sea of nitrogen and carbon monoxide ice, smooth and bright, its surface marked by polygonal cells and mysterious pits. Here the temperature is a frigid -230 degrees Celsius, -382 degrees Fahrenheit, cold enough that nitrogen, which is a gas on Earth, is solid and forms glaciers that flow like slow rivers. But Pluto is not a dead world. Its atmosphere, though thin, just 100,000th the pressure of Earth's, comes alive as the planet moves through its long, elliptical orbit. When Pluto is closest to the Sun, its surface warms just enough for some of the nitrogen ice to sublimate, turning directly from solid to gas. This gas forms a temporary atmosphere, blue and hazy, that hugs the surface and creates winds that can reach speeds of up to 30 kilometers per hour, 20 miles per hour. These winds, though gentle by Earth standards, are powerful on Pluto. They pick up grains of nitrogen ice and organic dust, carrying them across the plains, depositing them in new patterns, and sculpting the landscape into dunes and ripples. The New Horizons spacecraft, which flew past Pluto in 2015, captured images of these dunes, rows of dark, wind-blown ridges stretching for kilometers across Sputnik Planitia, shaped by the interplay of wind, ice, and sunlight. The formation of dunes on Pluto is a marvel of planetary science. On Earth, dunes are made of sand, shaped by the wind in deserts and on beaches. On Mars, dunes are made of basaltic sand and dust, moved by thin, dry air. But on Pluto, the dunes are made of tiny grains of frozen nitrogen and methane, moved by winds that blow only when the sun is near, and shaped by a gravity that is just 1/16th that of Earth. The result is a landscape that is both familiar and alien, a place where the laws of physics play out in new and surprising ways. The winds on Pluto also move glaciers of nitrogen ice, pushing them across the plains, carving valleys, and creating patterns that change with the seasons. As Pluto moves away from the sun, its atmosphere freezes and falls as snow, covering the surface in a fresh layer of frost. When the planet returns to the warmth of perihelion, the ice sublimates again, the atmosphere thickens, and the winds return, starting the cycle anew. The study of Pluto's winds and ice is a triumph of exploration and imagination. For decades, Pluto was just a point of light in the sky, its surface and atmosphere a mystery. But with the arrival of New Horizons, scientists were able to see the planet up close, to map its features, to measure its winds, to watch the dance of ice and air. The data revealed a world of complexity and beauty, a place where weather and climate are shaped by the slow, patient rhythms of the solar system. Pluto's nitrogen ice winds are not just a scientific curiosity, they are a source of wonder. To imagine standing on the surface, feeling the cold wind on your face, watching the dunes shift and the glaciers flow, is to dream of a world where the familiar is made strange, where the boundaries of possibility are expanded. The winds are a reminder that the universe is full of surprises, that beauty can be found in the most unlikely places, that the dance of the atmosphere is a story worth telling. The weather on Pluto also has lessons for Earth. It shows us the power of cycles, the importance of energy balance, the role of chemistry and dynamics. Shaping landscapes and climates. It reminds us that the air is not just a backdrop, but a living, changing system shaped by the interplay of sunlight, heat, and motion, even at the edge of the sun's reach. As you rest in this gentle night, let yourself imagine drifting above Pluto's surface, watching the winds move the ice, seeing the dunes form and shift, feeling the connection between the air and the land, the weather and the world, the past and the future. Let yourself wonder what it would be like to walk on Pluto, to see the sun as a distant star, to feel the cold wind, to watch the landscape change with the seasons, to sense the connection between the air and the ice, the planet and the universe. Pluto's nitrogen ice winds are a reminder that every world has its place, that every story is worth telling, that beauty can be found in the quiet, in the patient, in the enduring. The dance of the atmosphere is a lesson in harmony, in connection, in the power of nature to create order from chaos, and in the power of wind and ice to inspire awe. Take another breath. Let the story of Pluto's distant weather fill you with calm. Let the slow, patient journey of the winds remind you that not all dances are loud, not all stories are fast, not all beauty is obvious. You are a traveler in the solar system, a witness to the quiet dance of Pluto's winds, a dreamer in the endless night.